Thanks. I'm not sure how I'm going to live up to the extraordinary gentleman thing. I really was just a failed mad scientist. I'd like to talk to you a little bit about users and about the human beings that are connected in this machine-to-machine world. That's my whole focus, is how do we actually take all that information, how do we make it so that normal humans can understand it, so that we can use the way that our brains have evolved over millions of years and actually do something with that information and not feel overwhelmed and not blame ourselves that we're stupid because we don't understand what's happening with our application or in our building or what's going on. So I'm going to start with a little slide presentation. I'm a Macintosh user, so I've got to struggle through it with pushing my own button over here. Let's see if we can get a slide up. Have I lost everybody already? This is technology. Do you remember when life was young and computing was going to change the world? You know, technology, you sort of had life by the tail, and technology was going to do everything for you. For me, it was around somewhere in the 1960s. You can see me right there. I'm taller now. It was probably about 10 years after they realized that maybe the bit would be a good idea and standardized it, and it was about 10 years before they realized that the byte might be a good way to organize all those bits. And they kind of decided that. And I got excited, and I immediately jumped in on the bandwagon and started thinking about how could we take all these cool things, these bits of technology, these devices, and how could we converge them? How could we do something exciting with them? This was my first effort. I started small. I wanted to do a nice chair for my mom. I don't know if you can recognize anything on that chair, but this was really a massively networked Lazy Boy. It had integrated turntable and massively distributed toasting capability. You could toast just about anywhere on this chair, and you know, you get nicely browned bread. This was me trying to understand and integrate lots of products at once. I love devices. I moved in and started doing things like office furniture. You know, and I had holographic grass, and I had reflection pools so that people could have digital reflection and wireless wiring. It was very exciting. I wasn't addicted to technology. I wasn't just trying to put technology in places it didn't belong. I just loved it. I pretty soon moved up to doing entire buildings. This was an inflatable structure. Down in the Olympics, the idea was that it was architecture instead of architecture. And naturally, it had thousands of sensors all over it, and it was monitoring how the pressure was being held in that structure. And it was keeping that whole tension there. And this was to flow about 1 million people in 15 days, as Glenn said. Of course, we had experience pods where people could have different sorts of experiences scattered throughout the space. We were all thinking about how we could do that. Naturally, we had cell phones that were whispering your name in different languages as you walked by in sort of a waving grass garden. Of course, we had bubbles that all were Mylar, helium-filled, bar-coded bits of information that you could reach up into the air and grab and swipe in front of any one of the symbol scanners all over the place and actually pop up information. And if you could get the questions right, you got T-shirts. These were for kids. Kids learned how they could actually wander through information and how they could grab things and learn more about it. As I said, you know, I don't really like technology. I wasn't addicted to it. It's just, you know, I just had to keep pushing. So pretty soon we had bungee jumping performers coming from 90 feet in the air, 4 stories, diving over the crowds, 500 people, video projections, confetti cannons, digital reaction, bursting through the ceilings of video projection. Okay, maybe I have to admit that I had a little bit of a problem. I was a little bit addicted to trying to make really exciting experiences and really rich experiences with information, with technology, and with devices. So my name is Mickey, and I'm addicted to technology. You know, I guess it started, or at least I realized that I was addicted to technology when I tried to Borg my son. You know, the next big wave is biomechanical stuff. He lived through that phase. So welcome to the first session of Machines Anonymous. I'm going to try to help you break the addiction of machines. I think we can all raise our hand and say, I'm addicted to technology. I'm addicted to machines. I'd like to go through a few steps. I've actually got a 12-step program. We'll see how many we get through, and I'm speaking this afternoon to cover the rest of them. But I want to help you break the addiction. One of the things that we've noticed, and as a designer, I focus an awful lot on how users actually use things. And one thing we notice is that a lot of times technology is thrown at stuff, and you don't end up thinking about the user. You think about how I can put a new feature into something. And at the end of the day, all those machines, all that technology is just for us. It's for the user. It's so that we can do something better. It's so that we can see farther. It's so that we can reach farther. It's really to give us superhuman powers. So the first step in the program, as you guys I'm sure are aware, is to admit that we're powerless over the machines. Our life has become unmanageable. You know, when I was doing those massive installations, it was an effort of hundreds of people in many cases to keep the damn things running, to make sure that they kept going. There was no way to think about them as an ecology. There was no way to think that these would evolve in the wild, that they would keep running. We had to keep at it. And ultimately, we're powerless when we're set up that way. I think everyone's gone through this kind of a thing. I'm trying to program the remote control. I've got 6 remote controls. Am I the master of my own domain in my own house, or is the TV set? I would tend to think that the devices are ruling us. I mean, a lot of that's because I just can't get up and actually push the button on the TV set because I'm kind of lazy. But this is my inbox from this week. I circled how many messages are in the inbox. I haven't read through all of them yet. But I have around 10,000, 9,000 something messages in my inbox. I'll get to them, I promise. Who's running who? This is my question. The information seems to be taking over. When we were doing some of those massive experiences and trying to coordinate, in this case, flat panels wrapping around bridges that were flowing over water and having different sorts of content running on all of them and reacting as people walk through the bridge, this was hard. There wasn't a way to buy a pound of computing. There wasn't a way to buy an ounce of computing. I had to buy this multi-purpose, super-duper, turbocharged thing called a PC. And, I didn't want all the stuff that came with it. I just wanted to display stuff, and I just wanted to be, I wanted to render, and I wanted to pull from a repository. But instead, I ended up with all this other junk. I had to install 5 different patches. I had to install Windows Tuesday afternoon. I had to go through a lot of things. And when we're talking about thinking about users, talking about where's the ghost in the machine, the user who's making all those bugs for you, we've really got to think about scale. How are we going to deal with millions of people interacting with our space? So these are some questions that you have to just come to grips with and admit that you are powerless. I think part of the problem is the way that we understand computers today. And again, I would point to the PC because I can't buy a pound of computing yet. The PC has gotten us to this understanding that the information is in the PC, and that's the way we think about it. It's in the PC, and we've got to deal with this thing. And computing, and I'm going to gloss through this in a very non-technical way because I'm completely non-technical. I'm a designer. That's another 12-step program I have to go through. But computers, in my understanding, in my sort of simple cartoon picture, are made up of hardware and software. You've got computing today, and you've got hardware, and you've got software devices. And hardware, they're doing things like componentization, and they're doing things like putting more and more stuff on a single chip. And in software, we've got things like object-oriented, and we've got XML, and we've got relational databases. And those are actually good things. Object-oriented, decomposable small constructed. It's the kind of thing that you're going to need when you start to think about scaling in a huge way to actually deal with what I just showed you for a 15-day event happening all the time for everyone's lives. Things that are rich environments. But here's my question, computing today. Where's the user? I don't see him. I've got another question. Where's the environment? I just showed you some physical environments. And people don't think about the environment. I think you guys are probably the only people thinking about the environment at BuilConn and thinking about these kinds of things. But most people are not thinking about the environment. How are we framing it? And when I say environment, I don't mean the big eco-friendly environment. I'm just talking about like this room here. Where's this room in this picture in our cartoon world of the computing today? And finally, where's the information? If we're really going to flow information, sort of a worldwide stream so that we can pick it up with all these little devices and all these different sensors and be able to really think about how the users are interacting with it, how the buildings are interacting, how everything is interacting, we need to think about where that information is. Yeah, I will admit, I mentioned it, there are databases, there are relational databases, and those are okay, although if you pull out some of that data from the database and you don't have the key and you don't have the schema for it, it's a little hard to figure out what the heck it is. It doesn't have a portability to it. It's a little complicated. And it can't be evolved. You sort of have all the complexity embedded at the time that the database designer came up with the idea. And 5 years from now, when some new technology comes up, it's complicated and hard to build onto that existing data. And I think we've got things like people have been trying stuff with object-oriented, and, sort of embedding information into things and then streaming them to other places and stuff like that. And I don't think that necessarily will work. I think my picture of how that works is kind of like saying, look, I want to pick up a wave. I want to pick up this wave and I want to move it to another swimming pool. It's just not something that you can get a hold of. It's the surface of the information that you're interested in, not the substrate that's going on. And I forgot to also say that I'm going to say things that make no sense at all the way through this. So if you guys are all looking quizzically at me like, what the hell am I talking about? Just accept it. You have to accept that you're powerless. You're powerless, against my presentation here. So at the very least. So number 2 in the 12-step program, we came to believe that there was a power greater than ourselves that could restore us to sanity. My belief, and our belief at Maya, is that traditional engineering and design practices are not going to survive when we think about trillions of nodes, when we think about information centricity throughout the world. And I say trillion not lightly. Glenn Elmending yesterday was showing a slide that said that there would probably be an opportunity in 2005 for 5 billion processors to be in things, from handheld devices to scattered throughout. I think the problem is far greater than that. I think it's probably not only trillions, it's probably gazillions. I don't know if you know how many zeros a gazillion is. It's big. And to really live in this world, we can't do things that are top-down engineering. It's just not going to work. You don't have any complex, organic, evolutionary system that is designed from the top down. It has to evolve in the wild. So I think there is a greater power there, and there's a greater way to think about this. If we really are going to take the idea of pervasive computing, people have said context-sensitive computing. I think MIT's media or the review this week called it invisible computing. If we're really going to take it seriously, we have to think a little bit differently, a little bit broader about what computing is. Our belief is there are physical things. These are information devices. And then there are sort of metaphysical things, and that's the information. But my understanding and my thought about what information devices are is a bit broader than a PC. I think it's any device whose intended function includes capture, storage, retrieval, transmission, display, or processing of information. That means a piece of paper. That also means probably a CD-ROM is an information device, if you think about it. And it's a little hard to argue with that when you think about the RFID tags that are starting to get smarter. It's storing information. It's helping you translate it to something else. You could imagine that in reality, a CD-ROM drive here and a CD-ROM drive here on a network are really just network connectors for CD-ROMs. Fax machines are really just, network connectors for 2 pieces of paper. This is information. This is the way we process information. We look at information on paper. We look at information in other things. So to elaborate a little bit more on what I mean by information devices, I think there are hard information devices. You know, and again, I'd like to expand that. I think it's environments are actually information devices. I'm browsing this environment right now. It's organized in a particular way. It's storing information. It happens to be actually pretty context aware. You know, I can look at you guys, and this is what I see, and I've got it in my focus. And in the periphery, there's other stuff going on. So this is an information device, and you've got to think about it that way. Objects are information devices. Rick just talked about things, you know, little sensors and cell phones and other kinds of things. They're everywhere, and there are all sorts of opportunities. But I also think materials are coming on to be information devices too. You know, the thing he just showed was basically getting close to the atomic level. You know, we're talking about MEMS, and we're talking about things that are effectively smart materials. And this is happening. I think there are also some information devices that are soft. You shouldn't be able to make a distinction between a hard and a soft one. It processes, it does things, it stores information. We call this whole area infotrons. It's this notion of things that can store, retrieve, process information. I should be able to wire up a soft one and a hard one. I should be able to play with that. I should be able to allow things to flow. But there's also one more in there. There's a squishy one. So we've got hard, we've got soft, and we've got squishy information devices. I don't know if anyone understands what squishy information devices are. I think I just invented that around 2 o'clock this morning. Squishy information devices are humans. People are part of the system. People are part of pervasive computing. People can direct and tune systems. There's a wonderful book called The Wisdom of Crowds. And it really talks about this notion that a group of dissimilar people who are asked a problem of a lot of different sorts can actually get a better answer than the best expert. So people are part of the problem, and we've got to think about them as part of the problem and part of the solution, part of the overall information device network. On the metaphysical side, I think there's information architecture, and I don't think people pay enough attention to that. I call it IA. I don't know where it's at over here. But information architecture is really the structuring of information. I mentioned the bit and I mentioned the byte. Those are 2 of the sort of ground layers of something that everyone sort of agreed on. And I think agreed on is an important point here, so that we could have some currency in the world, so that we could start shifting around information. And then I think we have to think about the information itself. You know, when I dog-ear a page on a magazine, that's information I'm encoding in that magazine. I'm thinking I want to save that page. The information itself is important. I think what we're probably going to need is something one step above the bit and the byte. Probably not much more. We might want something like a universally unique identity, so that we could shuffle this stuff all over the world and we still know what that piece of information is. And when I say universally, I mean universally in the universe. So generate a really big number. And then attributes and values. Putting things together, the name and the actual name, my name, Mickey. Putting those things together is probably the minimum you could do to agree on syntactically as a little bit more layering of information. But at that point, you can start flowing it all around the world. You can let the information devices figure out how to actually use it, how to process it. I think that what's going to happen is when you start thinking about things this way, you'll realize there are trillions of these, probably gazillions of these devices out in the world. So we're really going to have to think hard about how do other things get solved when you have really huge numbers, when you have giant amounts of stuff. Do we have any other samples of things in life that actually have huge amounts of things that actually really are in the gazillions? Well, this is really interesting. I found this, see, I keep looking over here. Sometimes it's over here. You guys are going to have to pardon me. I'm a bad user. I just apologized. In the 1950s, this guy in New Zealand developed this thing called a MONIAC. And, you know, this was right around the time that they were building giant computers for everything. And so he built a computer to visualize the economic system. And it was actually based on water flow. So this thing actually had liquid flowing back and forth. And it was used to demonstrate and think about how economic systems work. And it turns out that economic systems are one of the only things you can point to today that have proven that you can't do top-down management and that have proven that humans can develop something that is actually an organic, complicated, complex system. And we have to start thinking about economists. We have to start thinking about how do we simulate, not a snapshot, but the flow of information and the give and take and the propagation of that stuff. I think we also have to change the way we think about how these information devices live. It's not information inside of a PC. It's PCs, cell phones, everything else, scooping out of the liquid information flow. You know, and I think you guys are paying down the initial seed payment on that with the stuff that you're doing. But we have to think really hard about this, and we have to consider the fact that there are squishy people in there. There are humans in the information flow. When we did that pavilion down in Sydney, you could grab bubbles of information out of the air and you could swipe them and find out things. And the only way you could find that information was by grabbing it out of the air, and it was a way to sort of viscerally understand this. This black slide means that there's probably another of the 12 steps coming. So that's about the kind of technical geeky stuff. The other part of this is we need to make a decision to turn our will and our lives over to the inevitable dawn of the attention economy. Attention is the new economy. Will I pay attention to you, or will I pay it to that crazy inbox that I have? How much will I pay? Users are going to be lost in this sea, this huge amount of information. And attention is going to become more and more important to them. That's what they're going to care about. I also put up a number that I'd like everybody to think about when they're designing systems. 7 plus or minus 2. 7 plus or minus 2 is how much a human being, you know, we have cognitive psychologists on staff, and they'll beat this into my head, and I'm humble now for it. Human beings can only pay attention to 7 plus or minus 2 things in their attention, in their focus area. They've got lots of really huge amount of bandwidth in their periphery, in the ambient world, but in their focus, they can think and deal with 7 plus or minus 2 things. That's why you can remember a phone number. What that leads to is some new patterns, some new design patterns about how we think. And in fact, I believe that pervasive computing is the only answer to handle a trillion nodes. So where it is what it is. If I put something over here, that's what it is. For hundreds and thousands of years, we've been piling things up. We pile pieces of information. We get halfway down the stack. Oh, that's that report that I meant to give you. I look over here and I shuffle through that. Oh, this is the thing. I have this incredible amount of bandwidth in the spatial realm that we're not tapping into at all, that you guys could with environments, with buildings. So we came up with this mantra, where it is what it is. It was part of our early work for digital computing and looking at how a person organizes their information around their work area. I wanted to show you kind of the seeds of contextual computing at Maya. This was an ancient program written in HyperCard, but it started to think about where it is what it is. So right now what you're looking at is every single document that I have on the hard drive. Well, this is a hard drive back in 1989. And all those things are just randomly organized here, but maybe I want to organize them slightly differently. I think I want to actually organize the x-axis by date. Okay, so now I've got everything by date. Now I can go and do things like, you know what, I only want to see stuff from here to here. Right now I'm starting to think about things spatially. And like, oh, it's all right in that middle area. Oh, it's all over here. And I can start to deal with a lot more information. Now that's just silly. I'll leave the X random. I think instead what I want to do is maybe do the Y by date. That's weird too. Let's see what happens. Oh, so I can peel back the Y forward and backwards. Maybe it would help if I could use the Z dimension. Again, people are used to thinking in 3 dimensions. I'll organize the Z by date as well. Ah, okay. You know, now stuff that's recent is in front of me. It's close. I keep it close to hand. Stuff that's far away is behind me. I can pull back all that stuff that's way behind me and slice in right around April, I think it was. Yeah, I want to look at only those documents. So I show this to you because I just want to show you kind of a really insanely baby HyperCard stack from 1989 about context awareness and how that works. Now, I'm not going to be able to get through too many of these pieces and parts of our 12 steps today. But taking the notion that context aware is important, that organizing your space. We've done systems where we organize across multiple things. This is your desktop. This is all of your team's desktop. So that you can start organizing things makes a huge difference. Thinking also about where the information is in the flow. When you look at this diagram, when you're close to a building, you need to know some stuff. When you're in the building, you need to know something else. When you're moving through the system, you need to know something else. So staging it so that the context isn't overwhelming. So I've got one more. We made a searching and fearless moral inventory of ourselves, our approaches, our practices. You have to realize that traditional engineering is not going to work. It's not going to be comprehensible. You know, it's going to take armies of people to try to keep these things running if we're not careful. It's not going to be tractable. We're not going to be able to slice in and figure out what's going on, and it won't be scalable to the size that we're talking about until we start to take these things seriously, until we start to think about 1 trillion nodes. You remember that bunch of emails? I've got about 10,000 emails in my inbox. I want you guys to get a sense of numbers, the tyranny of large numbers. Anto, I need your help for something. I want to take those 10,000 emails that are in my inbox from this week, and I want to give you a tangible sense of this. Because again, I think context awareness is really what's going to help, putting the environment into the space. So Anto, come on over here. Help me with this. Ready? 1, 2, 3. All right. All right. That's not 10,000 yet. We need more. 1. Here we go. No, that's not 10,000. But we're getting close. All right. I think. All right. This is the tyranny that I face when I get home and actually have to deal with all the information. I've got to wade through it. It's tripping me. It's making my life hell. Yeah, you can go home. Okay. Look at this. I'm going to make it really hard for our next presenter to talk. This doesn't bother anybody, does it? It's okay. I can leave this stuff. So you start to see, oh, look, waves are forming, and I've got a pile over here. And I'm instantly thinking about this from the standpoint of how it's spatially organized. Looks like physics are taking effect, and I've got kind of a drift. One last piece of the puzzle. I think it's useful if you've got some way to organize all this stuff. There we go. I cleared it up a little bit. The information in my inbox is not looking as bad today. Of course, you know, occasionally people are sending me like mean things. So it'd be nice if I could do something like that. You know, I'm getting scattered with information. Now, I do want to point out that I'd love you to take these balls because I really don't want to ship them back. Just like I really don't want all the emails that I've got. Okay. I've got one more slide, and then I think I'm done. If you'd like to hear more about some practices that you can actually put into effect, come to the afternoon session that I'm talking at. I'll give you one last one. We have to admit to the user, to ourselves, and to another human being the exact nature of our transgression. You know, sometimes we'll slide back and just fall back in love with technology again. You know, if you find yourself torturing machines, it's time to admit that you've fallen off the bandwagon. I decided that what I would do is try to train my dog to handle all my emails. My dog is one of the early versions of the Sony Abo robot. We talked about robots in the future. Well, you know, users can do things that the people who designed the robot could never think of. And one of the things we found out is that little Abos love to fetch balls. Thank you very much.